Hello everyone, welcome to the channel Chemical Engineer. I am Sahil Yadav and we are going to start our course on chemical reaction engineering. So we have a previous video, so if you haven't watched our previous video, please watch it. The link is in the information section. So last time we discussed about the overview of chemical reaction engineering and what is its syllabus. So its syllabus comprises of chapter 1, that is having a name of basics of kinetics. So we are going to start with this chapter. So if you haven't subscribed us till now, please subscribe me, as well as please join us on Telegram. And in Telegram you have to search Chemical Engineer 2120. You will get our channel named Gate Chemical Engineering. Alright, so let's start the video. Okay. So what we are going to cover in this 10 to 15 minute is this. So first we will go through the rate of reaction. What is it? What is its definition? How we express it? And what it depends on. Okay. So these four things we will cover for rate of reaction. Second, we will cover about rate law. What is rate law and how it is important to us. Then we will see a mole balance equation, that is the main aim of this video, mole balance equation, that we will see. And then in the final slide we will see the uses of rate equation. Okay, so let's start. So the first topic of chemical reaction engineering is rate of reaction. I advise all of you to please note down all the things that are written on my slide. That will help you, of course. So first, what you will learn in chemical reaction engineering is rate of reaction. So for simplifying it, let's divide the definition in rate and reaction. Two terms are there. Okay, so there are two terms, rate and reaction. So first we will define rate. Okay, so rate of reaction tells us how fast a number of moles of one chemical species are being consumed to form another chemical species. Like suppose we have something like A, which is doing some reaction and giving product P. So what rate of reaction does is it shows how fast is this decomposing to form this. Okay, this is a simple definition of rate of reaction. Now we have a one term here, number of moles. So to clear it, we know that moles is weight divided by molecular weight. It is nothing but a weight divided by molecular weight of any species. Like suppose here we will have weight of substance A divided by molecular weight of substance A. This will be our moles. We define it by N. Okay, so this must be clear in your mind by now. If you have any doubt, comment down. Okay, so moles is weight by molecular weight. And rate means nothing but changes with respect to time. So we have the first definition of rate of reaction term, that is rate, changes with respect to time. So what things are changes here? We have defined number of moles. So changes in number of mole with respect to time will be our rate of reaction. So we define it by number of moles divided by time. So if we want to say change, so we will see right here delta n by t, where t is the time. Okay, so this is all about a rate. Now second term is reaction. So now when will you call something is reacting? You may not call anything lying on a floor that it is reacting. Okay, so we say a chemical reaction had taken place when a detectable number of molecules of one or more species have lost their identity or assumed to have a new form by changing in its kind, number of atoms, or by changes in structure or configuration of atom. So when we call something a reaction, so we call something as a reaction when we find a detectable, means we can measure it, number of changes in molecules. Okay, it may be due to those molecules have taken new shape by changing its atomic structure, okay, or by transferring number of atoms from one form to other form. So this is why we call it as chemical reaction. And if you see it properly, it is nothing but a mass balance equation, like changes of one form to other form, like changes of atom configuration from one form to other form. There is no loss of atoms, they are not generated, but they are changing its configuration. So this is why we call it as a mass balance also. Okay, and now how these changes can occur in chemical reaction. So there are three major definitions, like they can decompose, like suppose we have component A which decomposes into B plus C. Okay, so that is called as decomposition, that is one component is decomposing into one or more component. Combination means nothing but we have A plus B which is forming C, that is combination of two forming one component. And isomerization is nothing but the change in configuration, like this A, it will be A but having different properties, we call it as A dash, like these are to the this part isomer, cis and trans isomer for propane, no it's butane. Okay, so this should be clear in your mind, what is rate and what is reaction. Okay, changes with respect to time is rate, reaction is something which is lost and forming to other thing. So this slide is done. I hope you are clear. You can ask doubt, please write each and everything. Okay, now how we describe the rate of reaction. So rate of reaction is described by minus small r, and suppose for species A we are talking. Okay, this should be clear. A is nothing but it can be anything, we have taken a dummy, so minus RA. Okay, so this is how we define a rate of reaction. So rate of reaction is number of moles of A disappearing or reacting per unit time per unit volume. Okay, so number of moles disappearing per unit time per unit volume. Okay, so this will be our rate equation. Minus of RA will be number of moles disappearing per unit time per unit volume. This will be our rate of reaction. Simple. This is how we define it. Okay, now why we are taking minus, and you should be having doubt. So we are taking, suppose a reaction is taking place, like A gives some product P. In order to describe it, we write reactant is disappearing, means it is losing. So we write minus of RA. And suppose we consider this as an homogeneous reaction, it will be equal to formation of RP. How we are getting this we will see in the next slide, but simple mass balance, losing of molecules from A is equal to number of molecules becoming P. Okay, what will be unit? So mole is having unit of mole, time is unit having second or minute or hour, and volume is nothing but a meter cube or liter. So mole per second meter cube will be the unit of rate of reaction. Now you can see something like mole per meter cube. What is it? You might know that mole per meter cube is concentration. Concentration is nothing but mole per meter cube, mole per volume. Mole divided by volume is nothing but a concentration. So that is what we have written here. That is minus of Ra will be change in concentration divided by change in time. Simple. Here I have written for reactant side we take negative, for product side we take positive. This is general convention. Okay. Now how can we change this rate of reaction? Suppose something is reacting, disappearing, forming, anything is happening. How we control it? So rate of reaction is controlled by parameters such as concentration, species concentration, temperature, pressure, and type of catalyst. Okay, so this T, P, X, Y, and type of catalyst and its suitable conditions. These 6 things are important to change the rate of reaction. Okay, clear? Now the rate equation is independent of type of reactor. Okay, so this equation remains universal truth, like it doesn't change with the type of reactor. We will see in upcoming videos various type of reactors, but this equation is applicable on each and every reactor as it is. Okay, here first line is it is an algebraic equation. Okay, so you can solve algebraic equation if you are doing mathematics. So these equations can be like in a form of linear equation having a power of 2, 3, 4, any, or it may have some complex structure as well, like having a power of 1 at the numerator and 1 in the bottom denominator. So it can be solved. Okay, rate equation can be solved. I hope you are clear. If you have any doubt, please comment with time so I can clear it. Okay, so this is about how we describe rate of reaction. Now let us see some expressions of rate of reaction. Like I have discussed it. First is based on the volume of fluid. Suppose in a tank we have a volume of fluid Vf. So we will write its rate as rate of reaction is equal to 1 by volume of fluid into moles of I formed. This is for product. Okay, we are not here we are not writing minus because we are considering product I. Okay, then based on unit mass of a solid in fluid solid system. So for solid, what we will do, this remains constant. Okay, change in number of moles or moles formed divided by time will be constant. What we will do, we will change the volume term. So here we are taking mass, here we are defining it by W. Okay, so V will be replaced by W, mass of a solid in a fluid solid system. Now for gas solid system, if there is a mass transfer taking place on a surface, what we will do, we will take a surface. Okay, moles per surface per time. Pretty simple. We write for mass, we denote it by R dash. For surface we are defining it by R double dash, and then for volume of solid in solid gas we are defining it by R triple dash. Now if we want to consider it by a volume of reactor, we can change that volume term by V of R. If we want to compare by volume of solid, we can change that term by V of S. So these are the 4 to 5 equations that you should know how to express rate equation. All right. Now the last or the second last topic of this video is mole balance. Mole balance is nothing but, if you know the mass balance, same thing is applicable in mole balance. Now suppose we have some system, some product we are giving. Suppose J is the name of a product we are giving to a system, and final it is producing J. J naught is the initial product, J is our final product. This is system. Okay. Now we are giving this to the system and it is producing a product. This is our product. This is our product. This is our feed. Okay. So simple material balance we will do. Suppose it is going into the system with a flow rate is in a terms of meter cube per hour, kg per hour, anything like that. Okay. Here we will take in terms of mole per hour, suppose. So its flow rate is Fj naught, means mole per hour. Okay, it is going inside the system with this flow rate. These moles are going inside with this rate. Okay, so and they are coming out with a rate of Fj. Okay, these two letters should be clear. Then I will move forward. Mole per hour, same unit. Okay, now what will be happening inside the system is this thing is changing into this thing. So what it will do, it will lose, or we can say it will disappear. Sorry for slow writing. Or it may lose and new product like J will be formed. J naught will lose and J will generate or form. Okay, this is clear in your mind. So what we will do, we have a simple mole balance equation. Rate of flow of J naught into the system, this is this Fj naught. Okay, minus rate of flow of J out of the system. So difference we will get, like this is going in minus that is coming out. So inlet minus outlet plus generation, like this is what is we call as generation. Here we are taking homogeneous, like suppose 100 kg of J naught is converting to J, means 100 kg disappeared from J naught is converted to 100 kg of J. So we are writing it as generation G of J, okay, is equal to accumulation. So going in minus coming out plus generation. Here something is generating, generation. So inlet minus outlet plus generation is equal to accumulation. Accumulation means this term, disappearance. Okay, is it clear? Simple mass balance equation it is. I hope it should be clear in your mind. If not, please ask me. Now there are various terminologies like how is it generating. So same unit is there, mole per time for each and everything. So what we are doing, we are doing manipulation because we are engineers. So generation is having a unit of mole per second, suppose. Now mole per second. So what we will do, we will try to incorporate rate rate of reaction term in this equation. So you know that what is unit of rate of reaction. So rate of reaction is having a unit of mole per meter cube into second. So what we will do, we will multiply it with a meter cube so that we will get mole per second as our unit. So we are writing this generation term as R of J multiplied by volume. Okay, is it clear? We are writing generation term by rate of reaction multiplied by volume. Now this thing we will put in this equation. So what will we get? F of J naught minus F of J plus R into change in volume. Here what we can do is we can do integration of this volume from 0 to V, and we can write here d of V. Same thing is equal to dN by dt, where N is nothing but a moles of J, moles of J generated, or moles of J at time t. Okay, clear? So this is our mole balance equation. I hope it is clear, because this is the basic, because everything I will going to explain to you is based on this equation, so it should be clear. Okay, so this is mole balance equation. Now uses of rate law. So rate law, you can tell me now from this four equation, what are the things we can get from rate equation. Here we have a rate equation. What we can get? We can get concentration, we can get time, we can get concentration at particular time. Okay, please write it down. What we can get through rate equation? We can get concentration of any species. Second, we can get concentration at particular time. Third, we can get a time for reaction. Fourth, we can get here volume of reaction, volume of reactor, or volume of anything, volume of fluid, volume of gas, anything that we can get. Okay, so moreover, if we get the volume, our main aim of studying chemical reaction engineering is designing of a reactor. So once we get a volume, we can design a reactor. Once we get a time of reaction, we can design a reactor. Once we know how concentration changes with respect to time, we can design a reactor. Okay, so this is the basis for our next videos. Okay, for next video we will see rate equation for various type of reactors. Okay, I will discuss type of reactors before it, and then rate equation for type of reactor. Okay, so this is done. You should remember all those equation. So what up till now what we have covered? Chapter 1 completed of Levenspiel book, and chapter 1 half completed for Fogler book. Okay, so please refer those books. If you have any doubt, you can directly message me on Telegram, or you can comment below on this video. All right, thank you for watching. Stay connected.